So here in section 3, we're going to work on performing function operations. These are really familiar to you already. We're going to add, subtract, multiply, and divide polynomials. So you've already done that in a number of different sections of both Algebra 1 and Algebra 2, so that's completely review. But then we're going to work with making function compositions, and that's going to be a little bit different, but it's also very, very simple to accomplish. And then we want to talk about our vocabulary. We're going to be working with power functions. Those look like this. Y is equal to a times x to the b power. We call it a power function because we've got the variable being taken to a power. That's what we're talking about. And then the composition of a function is really, we're going to look at a little graphic piece later. The idea is that I'm going to combine two different functions together to make a new function with a new purpose. So we'll talk about that when we get to that section. Okay, types of problems we might do using composition is this idea here. We have a $10 gift certificate to a paint store, and in addition, the store is offering 15% off my entire purchase of paints and painting supplies. So I'm going to go buy a $30 can of paint and $25 worth of painting supplies. And I want to see, well, which is better for me, to take the gift certificate off first or to take the 15% off? So if I do a composition of a function, if I write a function that shows how much I pay for any amount of purchase using the gift certificate, and then I write a different function that shows how much I pay taking 50% off my order, if I combine the two functions, it will take the $10 gift certificate off and apply the 15% off all at one time, instead of my having to put an input into one function and then take that output and put it into the next function. I can make this new function that does both things. And what's interesting is the way in which I make the composite will change whether the gift certificate is applied before the 15% discount or whether the 15% discount is applied before the gift certificate. So when we get to the end of this, then that's what we'll be talking about. So these are function operations that you're familiar with: addition, subtraction, multiplication, and division. And there are examples here. So we have f of x and we have g of x. And the reason the letter is changing is just so we can tell them apart. Those are basically names, right? If I just put y equals 5x and y equals x plus 2, then I wouldn't know how to refer to them. But if I call them an f function and a g function, then the idea is that we're going to make a new function by adding them together, or subtracting them, or multiplying them. So just make sure especially when you're adding and subtracting, that you're going to put parentheses around, well, and multiplying too. You want to put parentheses around the item to make sure that you don't make a mistake. So remember that you're taking the value of this entire function and either adding or subtracting the entire function from it. Okay, so, and the same with multiplying. You'd be multiplying this function times that entire function. Okay, and the parentheses will help you to not make mistakes. So if we look at some examples of this, if I want to add functions, I've got an f function and a g function, and if I want to add the two functions together, I'm going to take the f function. That's the f function. And I'm going to add to it the g function. I'm keeping parentheses. Now, in all practical sense, when I'm adding, nothing really changes when I take the parentheses off. It's just important for you to keep these really good habits of putting parentheses on things when you're saying one value plus another value. If those values have multiple terms, it's best if you just start off by putting parentheses around them and then appropriately take the parentheses off and combine like terms. That's what we're going to do. When I combine with the plus, nothing really changes. And when I combine like terms, x to the 1/3 power, these are like terms. And then x to the 1/2 power, those are like terms. So I have -3 plus 5, x to the 1/3, that's going to be 2, x to the 1/3. And I have 4 plus 4x to the 1/2, that's going to be 8x to the 1/2. And that's adding the functions together. Okay, if I take and I do subtraction, right, now this is where it's really going to be important that I use the parentheses, because that ends up creating the need to distribute multiplying by -1, and that's going to change all the signs. All right, so now I've got my f function minus my g function. When I take parentheses off, right, nothing changes in the first binomial because what's out here is +1, but here it's -1, so -1 times 5 to the 1/3 is -5x to the 1/3, and -1 times 4x to the 1/2 is -4x to the 1/2. So now I've got -3 minus 5, that's -8x to the 1/3 power, and I have 4 minus 4, that's 0x to the 1/2, so it's just this. Okay, so that should be very familiar to you. These are the problems I'd like you to do for practice. Do problems 5 and 8, and then come on back to the lecture. So now let's take a look at multiplying and dividing. Again, these are multiplying and dividing polynomials. This is actually a lot easier than what you've been doing because this just has a single term in each. It's really quite simple, right? So I have 4x to the 2/3 and 5x to the 1/2, and I'm going to multiply them together. 4 times 5 is 20. And then x to the 2/3 times x to the 1/2 is x to the 2/3 plus 1/2 power. When I multiply with the same base, I add the exponents. Right, so I'll need common denominators. Those will be sixths, so I'll have 4/6 plus 3/6. So I end up with 20x to the 7/6 power. Okay, so I'm still using the properties of exponents. It's just that now my exponents are integers, or sorry, aren't integers, but they're fractions. So I have to now go back to refresh my memory on adding fractions. So I created common denominators and then added the numerators. Okay, if I'm going to divide, I'd have 4x to the 2/3 power in the numerator. That's f of x. G of x is in the denominator. 4 divided by 5, that either could be made a decimal of 0.8 or a fraction of 4/5. That's what I'm going to do. And then I'll have x to the 2/3 minus 1/2 power, because when I am dividing items with the same base, I subtract the exponents. There's still going to be 4/6 and 3/6, but 4/6 minus 3/6 is going to give me 1/6. Okay, and that's that. Okay, so pretty straightforward review of things you already knew about properties of exponents and multiplying and dividing polynomials. Go ahead and work on problems 13 and 17, and then come back. So this is the graphic that I was talking about compositions of functions. So here we've got a function f, and so I have inputs and then outputs. So I plug x's in here, and then they go over here and they become outputs of the first function, the f function. Then if I were going to take those outputs and plug them into the g function, they create this intersecting set, the members of the outputs of the first function that are inputs of the second function, and then it would go through to here. So this is similar to our idea of I have a $10 gift certificate and I have a 15% discount. So if I did the discount here, the $10 gift certificate here, it would take the price and subtract 10, and then I'd have a new number here. And then I'd take that number and I'd plug it into the g function, which is going to give me a 15% discount. And that's what I'd end up with. Okay, so hopefully that makes sense to you. So what we're doing is we're taking two functions and we're going to combine them together into one function that performs both of the operations of the relationship of the two functions in one single function. So here's an example of what that sort of looks like First, I'm going to do this as a two-step idea. So before we know how to do a composition of a function, what happens in process here? So I have f of g of negative 3. So what this tells me is I'm going to take negative 3 and I'm going to plug it into the g function. And then I'm going to take that result and add it into the f function. So let me take the g function. So I'm going to do g of negative 3 would be equal to the opposite of negative 3 squared. So negative 3 squared is 9 times negative 1 is negative 9. Okay, and now f of g of negative 3, right? G of negative 3 is equal to negative 9. I take negative 9 and I plug it into the f function. So negative 27 plus 2 would be negative 25. So f of g of negative 3 is equal to negative 25. Okay, so I plugged a number into one function and then I took the answer and I plugged it into the next function. But if I combine the two functions together, I'd only have to plug the negative 3 into that new function that combined the two. Okay, so I'm going to show you what that looks like. First, I'm going to take the h and the g function. I'm going to make a composite. Right, and the way I do that is I take the g function, right? The g function is here, and I'm going to plug it into the h function in place of x. So I'm going to take negative x squared, that's the g function, and it goes up here in place of this x. So if I go ahead and I create a composite of this function, I'm going to take, right, as I said, I'm going to take this and I'm going to plug it in place of x. So I have the opposite of x squared minus 2 divided by 5. I don't know why I wrote it so low. And then if I want to go ahead and plug 5 into this, it's going to be the opposite of 5 squared minus 2 over 5. So 5 squared is 25. The opposite of 25 is negative 25. Negative 25 minus 2 is negative 27 over 5. So just to show you that if I had done it as a two-step process, that would be the same. I have g of 5 is equal to the opposite of 5 squared, which is equal to negative 25. And if I take that and plug it into the h function, I'll have negative 25 minus 2 divided by 5, which is negative 27 over 5. So you see I get the same answer. It's just up here I did it in pretty much one step. Okay, so combining the two functions allows me to take this relationship and incorporate into this relationship so that what we get is the combined effect of the two different relationships. Okay, to show you this one more time, if I want to find f of g of x, I'm going to take g of x, I'm going to plug it into the f function in place of x. So f of g of x will be equal to 3 times 2x minus 7 to the negative 1 power. So you'll notice I didn't change the coefficient, I didn't change the exponent, I just took g of x and I put it in place of x. This is going to be 3 over 2x minus 7 when I simplify it. Okay, so that's the composite. I can also combine a function with itself, so I want to find the composite of the f function and the f function. So in that case, I'm going to have 3 times the f function, which is 3x to the negative 1 power, to the negative 1 power. Now, when I take a power to a power, right, this is 3 to the first power, I'm going to multiply the exponents. So this becomes 3 times 3 to the negative 1 power, because 1 times negative 1 is negative 1. Negative 1 times negative 1 is 1. And I know that this is 3 times x over 3, because 3 to the negative power is the same as 1/3. And when I multiply those together, the 3's cancel, and I just get x. So f of x is equal to just x. Okay, so go ahead and practice that. Do problems 21, 22, 29, and 30. Come on back and we'll solve that word problem. So the key element to remember is that if I want to write these two functions, let's say I write an f function that takes off the $10 gift certificate. So it'd be the amount I spent minus $10. And then let's take the 15% discount. So g of x would be equal to 0.85 times x, right? Because 85% is 15% less than 100%. Okay, now what's important now when I start thinking about doing composites, if they want me to find the sales price of my purchase when the $10 gift certificate is applied first, that would mean I'm going to do g of f of x. And what this will do is it'll do the f function first, which is taking $10 off. And then it will do the g function, which is getting a 15% discount. So I'll get 0.85 times x minus 10. Okay, so I took the f function and I put it here. Now, if I want to find f of g of x, which would take the 15% discount first and then take $10 off, I'm going to take this f function, 0.85x, and I plug it in place of x. So it's 0.85x minus 10. If I this one's fully simplified, but if I simplify the other one, I'll get 0.85x minus 10 times 0.85 is 8.5. So if you want to know which one's better for me, obviously the first one is. I'm sorry, the second one is. My mistake. Right? Quite obviously the second one is because here, you'll notice in both cases we're going to take this 15% off. Right? But here I'm only going to take off $8.50, and here you're going to take off $10 once I'm done. So this is the one I like the best. Right? If we want to find out what I actually pay, I've got $55 worth of stuff. If I take 55 and I plug it in here, $0.85 times 55 minus 8.5. And we plug it in over here, 0.8.5 times 55 minus 10. I could go ahead and figure those out, but I'm not going to really bother to pull out a calculator to do this multiplication because you know I'm going to pay $1.50 less for this one than I'm going to pay for that one. Okay, so that's it for 3.3.